sample fraction of 3. I can use multiplication to get an equivalent fraction. Pick a number. 2. So if I want to use 2, I multiply the numerator times 2. Then I must also multiply the denominator by 2. I just made an equivalent fraction. Use 3/8 again. Pick a different option for multiplication. 9. So 3 times 9, 27. 8 times 9. Okay, that would be equivalent. Okay, so multiplication, you can use any number you want. Now, if they ask you to come up with equivalent fractions, you might not want to use the ones that are more difficult. One that works really well, 2 works well most of the time, 10. 10 works great. Why? So you're just adding a 0 to your numerator and denominator. Okay, those work well. That works just fine. However, division. I can take the fraction 12/20. I can make a equivalent fraction very easily with multiplication and say, okay, times 2 is 24, times 2 is 40. Great. But division, I'm kind of limited. I can't just pick any number I want to get an equivalent fraction using division. They actually have to have factors in common. So I look at a 12, I look at a 20. Right away, the first thing that pops out is that they're both even. I can divide them both by 2. If I do that, 12 divided by 2 is 6. 20 divided by 2 is 10. Okay? 6/10 would be equivalent to 12/20. However, if I'm using division to simplify a problem, sometimes they'll ask for it to be in simplest form, which you should be very familiar with doing because we've been doing that for, if you've been here since 6th grade, we've been doing that for 2 years. And that's why I was always so adamant that you made sure you simplify. They have 2 in common, but something larger that they have in common would be what? 4. So 12 divided by 4 is 3 and 5. 4, ironically enough, is also the what of 12 and 20? Yes, the GCF. 4 is also the GCF between 12 and 20. So if you divide numerator and denominator by their GCF, you will always get a fraction that's in simplest form. Now, I don't expect that for each of these problems that you need to put in simplest form that you're going to set up factor trees for 12 and 20 and go through that whole process of finding the GCF before you simplify. But just understand that that's the process that is used, and that's why we just spent a lesson on GCF leading in to equivalent fractions. Okay? Well, because it's not the simplest form. The simplest means we're going to use the smallest numerically numerator and denominator that I can that still means the same thing as the original fraction. Okay? When I divide, my numbers get, but when I multiply, they get bigger. Okay? So that's kind of what we're looking at. Take a look at page 185. 184. No, 185 is okay. So 12 through 19. The directions on 12 through 19 write 2 fractions that are equivalent to the given fraction. Do they give you any restrictions at all that you have to use multiplication or you have to use division? So you can give me 2 equivalent fractions using whatever method you want. So if you look at 6/12. Yeah. You can divide by 3. So Alex is using division for one of them. Yeah. You multiply by any number you want. It's totally up to you. If you give me 2 equivalent fractions using division, great. If you give me 2 equivalent fractions using multiplication, great. If you give me 2 equivalent fractions, one using division, one using multiplication, great. As long as they're equivalent, I don't care. It's up to you. Now, 20 through 27, however, you don't have that option. You do have to put those in simplest form. You'll have to use division there. Yep. You'll have to use division. Okay, but you've been doing that for a long time already. Okay, and based on time restraints, I'm going to stop there. So 12 through 27 for 185. I'll give you a redo if you hold on real quick. But that's the gist of it. And just very, very, very much review. So 185, 12 through 27. Redo. Page 211. Through 15. It was out of 12, right?